Hi everyone, we're going to take some more class notes and we're reviewing, this is our second day of reviewing for the semester, quarter 3 and quarter 4, and today's focus is just on the algebra piece of third and fourth quarter, which was our chapter on rational exponents and radicals and logs and exponentials. So starting number 1 or starting number 2 actually, I have to solve. This is a rational exponent, which really means that this is a radical equation. If you wanted to write it as its root, you could. So like if you wanted to say, okay, this is the cube root of n minus 26 squared, that quantity squared, plus 6 equals 10. So you can change it to root because in the section that we did solve, we solved radical equations rather than rational exponents. But remember, they mean the same. Bottom number is your index, top number is your exponent. So isolating the root, I'm going to subtract over 6. I'm going to get the cube root of n minus 26, that quantity squared, equals 4. Now to get rid of the cube root, I have to cube both sides. So my power sheet or base sheet says 4 cubed is 64. So I get the quantity of n minus 26 squared equals 64. Now to get rid of something that's squared, I can root or rational exponent, take it to the 1/2. But 1/2 power and root mean the same thing. I'm physically rooting, so I'm going to think plus or minus here. And so the squared and the root are going to cancel out, leaving me with n minus 26 equals plus or minus 8. Because that's perfect, it can come out. I add over the 26, and I get n equals 26 plus or minus 8. So I need to do 26 plus 8, and I need to do 26 minus 8. So that's going to be 18. And that's going to be 34. So I'm getting 34 and 18 are my answers for n. Number 4, I am asked to simplify. I recognize that I'm multiplying with imaginary pieces. I recognize that these are just monomials. I'm going to put those together first and say negative 40i times the quantity of 5 minus 4i. So negative 40i times 5 is going to be negative what? That's negative 200i. And then a negative times a negative is a positive. And that's going to give me positive 160i squared. And then I squared becomes a negative 1. So I'm saying negative 200i minus 160. Another way to write that, negative 160 minus 200i. Final answer, those are not like we can't put those together. 6, simplifying using my perfects, and this is a cube root, so using my perfect cubes, here they are, trying to find one of these numbers that goes into 128. 128, so I'm taking 128 and dividing it by 64, and I get 2. So I'm going to use 64 times 2 under the cube root. 64 times 2. This is a perfect cube. This is not perfect. X cubed is perfect. 3 goes into it evenly. Y to the 5th is not perfect. I'm going to break it up. Y cubed is perfect, and then I need 2 more. Perfect, not perfect. Z squared is not perfect. There's not enough z's for anything to come out of the jail. Perfect, the cube root of 64 will come out as 4. So I have a 4 outside. That's come out. This is perfect, comes out as x. All of these come out as something different. This was perfect, it comes out as y. I keep my cube root. Whatever is not perfect stays in the jail, which means 2 y squared, z squared staying in jail. Final answer for number 6. 8 and 10, we are solving. I recognize this is a log equation. I recognize I can condense. I see subtraction, so I'm going to make sure I divide. So I keep my log base 2. I work on condensing, showing x over x plus 2 equals 3. Once I've condensed, I recognize and understand how to solve a log, and the best way to do that would be to switch forms. base exponent equals the value. Go from log to exponential. The base, logs are equal to an exponent, and this is the value. 2 cubed is 8. And then you can solve by cross multiplying. You can solve by clearing your fraction. However you want to take that approach. I'm going to cross multiply and say x equals 8x plus 16. I'm going to subtract over the 8x. And negative 7x equals 16. Divide the negative 7. Seeing that I'm getting a negative answer, that's going to tell me that I have no solution, because remember, the value of a log can't be negative. So no solution there. And 10, I recognize I need to solve this. I recognize it's an exponential. I have a base, a power equal to a value. And so typically when I have exponentials, I try to use my base sheet and see if I can write 73 and 20 with the same base. 20, 73, not going to happen. So the other way to do that then would be to take and use logs. I'm going to use log base 20 on both sides. Log base 20 on both sides. So this is going to stay log base 20 of 20 to the k plus 9, and then this is going to be log base 20 of 73. I do this because we know that if the base and the values base are the same, the entire log is just equal to what the exponent is. So this becomes k plus 9 equals log base 20 of 72. And then to get the k alone, I subtract the 9. Not like, so I'd put that behind. And we can do this all in one step. Remember, this is just a number. So log base 20 of 72 minus 9 is what I'm going to plug into the calculator. To get that log base, remember we go to math. You can arrow up or down. You need to get to log base. And I'm putting in a 20 and a 73. And then on the outside, I need to subtract 9 from whatever that number is. So I end up with k equals negative 7.568. That's where it tells you to round for that one. And then we can have negative exponents, although it wouldn't end up being negative, so this is an okay k value. So just always checking when solving to make sure it's not a no solution or like a many solution problem. All right, that's it for today. Bye everyone, have a great day.